Well, welcome back. Today we're going to be discussing electricity in parallel circuits. Parallel circuits have multiple paths for the current. If you look down here at the bottom, you can see that these electrons are coming out of here. They get to right here, and now they have a path. They have a choice right here, which way they're going to go. Previously, there was no path for them to go. So what are some key things? They have multiple paths. For parallel circuits, you're going to find out the voltage across each device is the same. Well, that was different than yesterday. Now it's the current that's divided. The sum of the currents in all devices equals the total current. The sum of the currents is the total current. So if you had 1.5 amps here, and down here you have 0.25 amps, then we would say that total is 1.75 amps because we simply just added these up. Another thing you'll find out is a break in any one of the paths in a parallel circuit does not interrupt the flow of electric charge. Yesterday, when you were doing your lab with series circuits, when you disconnected one of these light bulbs, it turned the other one off. Well, hopefully you'll find out that in your parallel circuits today, when you disconnect one of them, it does not turn the other one off. Okay, here's our circuit board. What I want to show you then is how do we hook things up in parallel? Well, in parallel, everything's going to start from up here at this positive. And if I want to hook these, let's say I want to hook these three lights up in parallel. I'd hook a wire from here, and I would go to here with it. Then I'd hook a wire from back to here again, because they have to get that same voltage. I'd go there with it. Then I'm going to go back to the same spot and hook a wire to there. I don't know what quite has happened to our wire, but let's draw it in there again. Alright. Then, from the ending, I'm going to go from all three of these spots to the ending again. And that's in parallel. And what we mean by that now is if one of these wires would be disconnected, and by disconnecting it, I'm just going to erase it. Notice that the first light now, it's not Wi-Fi, the first light would go out. There'd be no electrons flowing there. But the next two wires still have a complete circuit. So the bottom two lights would still be working. So this is in parallel. Now let's talk about how we measure things today. All right, if we're going to measure things, voltage, well, VT, we're still going to be measuring by putting our probes right there. All right, again, if we want to find the total voltage, we're still going to put it right there. That's not changed from the very first day. If I want to find the voltage across any one resistor, well, that's not going to change. I'm still going to put my probes on the opposite ends of that resistor or light bulb. I'd put them here or here. This one here would be for V2. And then for V3, I'd put them there. So we've talked about voltage and we've talked about current, or voltage. Okay, again now, what I want to show us, if I wanted to measure VT, I've kind of drawn a picture here, and now we can kind of extend this. So I wanted to do VT, I would go there, and there. That would be for VT. If I wanted to do it for any one of the individual voltages, light bulbs, I would go across the light bulb. Measure there, in there. Remember that we're not going to be disconnecting any of the wires when we do voltage. Or, if I want to do the second one, I would go there with it. I kind of erased it there somehow. There. Or, as I said earlier, I would take the red one up here, and I would take the black one up here, and that's how we'd find those individual voltages. Let's talk a little bit now about finding currents. Well, I'm going to have to switch this over. Kind of lost the inside there a little bit, didn't we? Okay, I'm going to take my dial and turn it over here to 10 amp. And now I'm going to come out of the left side to measure amperage. Well, to do this then, to measure amps, to measure total amperage, I would have to disconnect all 3 wires here at the end, and I would take all 3 wires and hook them up here, and then I would take my black one to there, and that would give me the total current. All right, because now I have all 3 of these coming back together, running through the multimeter back over to here. That's how we'd find IT. To find the currents running through any individual one is going to be a little bit different. If I'm going to find the current running through the first one, then what we're going to do is I'm going to leave the second 2 still hooked up. Now I'm going to take the third one and I'm going to connect it here and run the black one over there to there. What am I doing now? The only one, I'm finding the current now through the first light bulb because it's having to go through the multimeter. So this would be I1. If I wanted to find I2, then I would disconnect the second one, run it to here, run the first one back over, and now I would connect that there. So when I want to find the current, depending on what I'm trying to find, that's going to be the one I'm disconnecting. I3, well, some of you may have realized already, to find I3 we're going to disconnect the last one, and we're going to run the last one over here, and I'm going to run it through. Now it's running through the multimeter and I can find its current. Well, let's take a look then at one more thing. Alright, here is a circuit diagram that I've made, or a schematic over here of a circuit, and on the right I have the chart. Well, plug in the givens. Alright, anybody should be able to plug in the givens. The total voltage, 10 volts. Resistor 1 is 5, resistor 2 is 10, resistor 3 is 20. You know what? We're going to hold off on this just for right now. I think the important thing would be for us to be able to simply be able to do this, the circuit diagram, and get to the parallel circuit. We're going to hold off on this for right now. Not too often, you don't have to do extra work. Catch you guys on the flip side.